Good morning, ma'am. My name is M. Varshasri. I am studying in second BTech first semester in CSM branch, and my roll number is 234G1A33I1. And today I am here to give a PowerPoint presentation on the subject Artificial Intelligence, and the subject code is 23CSM301 for the topic the decision trees. The introduction to the decision trees. The decision trees is also one of the type of trees which is used in the popular machine learning algorithm used for the regression task. They model the decisions and their possible consequences as a tree structure. The decision trees are the intuitive and the easy to visualize, making them accessible for understanding the complex decision making processes. Whereas the decision tree is one of the most simple way to understand the given data by dividing them into a many branches which can give the output in a very easier way. The structure of decision trees. A decision tree consists of nodes, branches, and leaves that represents the decisions and the outcomes. Each internal node represents a feature, each branch represents a decision rule, and each leaf node represents an outcome. In this given tree, the starting node is known as the root node, whereas it is further divided into the many branches that is known as the decision nodes, which are present in between the leaf node and the root node. The leaf node is known as the last level of the tree, and whereas the decision node, which represents the decision rule, which is present in between the root and the leaf node, whereas the leaf node represents the whole outcome which has driven from the root node and the decision node. The tree starts from the root node and branches out to represent the various possible paths and the outcomes. From this root node, as they are divided into the many subtrees, so the based on the input, the tree is further divided, which can give us the clearer way of an output and a possible outcomes for a given information. The decision tree terminologies. The root node. Root node is from where the decision tree starts. It represents the entire dataset, which further gets divided into two or more homogeneous sets. In this given tree, this starting node is known as the root node, where the decision of the tree starts from, and it gets divided into many subtrees which depends on the given input. Then the leaf node. Leaf node are the initial and the final output node, and the tree cannot be segregated further after getting a leaf node. In this given tree, the last level is known as the leaf nodes, which is represented in the form of the triangles or the square boxes. When the tree is reached to the leaf node, it can be further divided into any more branches, and it is the last step or the level in a tree. The splitting. Splitting is a process of dividing the decision node or the root node into the subnodes according to the given conditions. For the given information or for the given data, this root node or this decision nodes can be further divided into many branches or the many subtrees for our convenience, and the process which is dividing the root node or the decision node into the many branches is known as the splitting. But the branch or the subtree, a tree formed by splitting the tree. For as this is considered as the root node, it has further divided into the two branches. So this is one of the subtree, and here this point is known as the root node for this particular subtree, and for this particular left subtree, and for this particular right subtree, this decision node is act as the root node. The pruning. The pruning is the process of removing the unwanted branches from the tree. When we divide the root node into the many branches, and when we come across from the initial point of the tree where we observe the unwanted branches are present in a tree, if we want to remove the unwanted branches, then we can opt for the option pruning. Then the parent or the child nodes. The root node of the tree is called as the parent node, and the other nodes are called as the child nodes. This node is known as the parent node, and from which the branches are further divided. That's the divided nodes are known as child nodes, whereas this process has been divided, that particular node is known as the parent node. The how the decision tree works. Decision trees split the data into subsets based on the value of the input features. This whole decision tree works on the given input, and it can be divided into this further subset as given in this particular tree. The algorithm uses matrices like Gini impurity or entropy to determine the best split at the each node. This process continues recursively until a stopping condition is met, such as reaching a maximum depth or the minimum samples per leaf. In this given subtree, or in this given the decision tree, the decision what we must take is, should I accept a new job offer? And here it is considered as the root node. Salary at least $50,000. If yes, then we opt for commute more than 1 hour. If no, decline the offer. So we have divided this root node into the two child nodes. Child node, this is the left child node and this is the right child node. If yes, this two are the decision nodes which can be done, and if yes, commutate more than 1 hour. If this decision is yes, then you can opt for the decline offer. If no, offers free coffee. Then this is one of the decision nodes, and then if we move to the another decision nodes, offers free coffee. If this decision is yes, then accept the offer. If this decision is completely no, then decline the offer. These the information which is present in the oval shapes are considered as the leaf nodes. That means this cannot be further divided into any of the branches. These are all the things which cannot be further divided. So this is how a decision tree works, where the one decision is again divided into another decision. This decision is again divided into another decisions. The advantages of the decision trees. The decision trees are straightforward to interpret and visualize, making them user-friendly. They can handle both categorical and numerical data without requiring the extensive pre-processing. Additionally, they have non-parametric and do not assume any specific contribution of the data. One of the biggest advantages of the decision trees is that the particular input can be further divided into the many branches, and it gives the clear information for us. In this particular decision tree, the maximum depth levels, if we consider this root node as level 0, this one is the level 1, level 2 and the level 3. That is, the maximum levels are the 3 if we consider the root node as a 0. This root node is again divided into the two nodes, that is two branches, that is the decision nodes. This decision node is again divided into the two branches, that is the leaf nodes, whereas this can be again further divided into the branches as it is the leaf node. That means the process stops at the leaf node, and this is the final outcome which will be considered for the particular subtree. Whereas in the left subtree, the decision node is again divided into the two branches. One is the left node, leaf node, and another one is the decision node. Whereas the leaf node cannot be further divided, and then the decision node can be further divided, which is known as the leaf node and the leaf node. Whereas the process stops at the every leaf node and it cannot be further classified into many branches. The disadvantages of the decision trees. The decision trees are prone to overfitting, especially with the trees on a small data sets. They can be sensitive to noisy data, and small changes in the data set can lead to different splits. Furthermore, trees can become biased towards the features with more levels, which may skew the model's performances. There are many and few of the disadvantages in the decision trees, whereas it can be more overfitting to a particular information which is given as the input for then given output. They can be sensitive in the data set, whereas the initial data set is again prone to divided into the branches. It can be considered as a overfitting one in the decision trees. The pruning decision trees. Pruning is a technique used to reduce the size of the tree and mitigate the overfitting. This process involves the removing branches that have the little importance or that do not provide significant predictive power. Pruning can be performed using the methods like the cost complexity pruning or the reduced error pruning. Here, for the tree pruning example, this one is considered as an unpruned decision tree. This one is considered as a pruned decision tree. You can observe that in a pruned decision tree, the levels are the same as compared to an unpruned decision tree, but it gives the exact and clear information compared to a unpruned decision tree, and the branches are also lesser compared to this unpruned decision tree. The applications of the decision tree. Decision trees are widely used in the various fields including finance, healthcare, and marketing. They can be employed for risk assessment, patient diagnosis, and customer segmentation. Their versatility makes them suitable for both supervised and unsupervised learning tasks. This particular decision tree can be used for many purposes like the finances, machine learning used for the building blocks, for algorithms, handling the classification and the regression. In the medicine diagnosis process of the health conditions based on the symptoms and the medical history. In the education process, it can be used in the prediction of the GPA of a particular student. The decision trees versus the algorithm. Why one should opt for the decision tree in comparable of the other algorithms in the machine learning. Compared to linear models, the decision trees can capture non-linear relationships more effectively. Unlike assemble methods such as random forest, single decision trees are simpler but may lack the robustness. Understanding the differences helps practitioners choose the right approach for the specific problems. This decision trees is very useful as it is a non-linear one. That means the given data set can be further divided into the many subsets, which gives the information in an appropriate way and which gives the result, the final result or the final outcome by using the various branches of the tree. The ensemble the methods with the decision trees. Ensemble methods like the bagging and the boosting improve the predictive performance of the decision trees. The random forest. A popular ensemble method combines multiple trees to enhance accuracy and reduce the overfitting. The boosting techniques such as ADA boost adjust weights on the misclassified instances to improve the model performance iteratively. As we have seen, one of the disadvantages of the decision trees that is known as the overfitting, this can be overcome by using the random forest, which combines a multiple trees to reduce the overfitting. Here we can see the multiple trees are combined together to reduce this overfitting process. The conclusions and the further directions. Decision trees remains a fundamental tool in the toolkit of the machine learning practitioners. Further advancements may focus on improving their robustness and interpretability through the hybrid models. As artificial intelligence continue to evolve, the decision trees will likely adopt and integrate with the new techniques and tackle the complex problems. The decision trees is one of the best algorithms for the final outcome, which can be processed through many levels in a tree, and it can be useful for many inputs and it gives an appropriate information. Thank you so much for giving this opportunity to give a PowerPoint presentation on a specific topic, the decision trees.